Well, this is the last video, region bounded by a polar curve. The area of a region bounded by r equals a function of theta, and the rays, theta equals alpha, and theta equals beta, is 1/2 the integral from alpha to beta of r squared d theta. R is some function of theta. Integrate r squared d theta from alpha to beta and multiply that by 1/2. We will talk in class about where this formula comes from. The first example we're going to do, I think this will be the only example for the video. Find the area inside the circle, which we're going to draw blue. The circle r equals 3 sine theta, and the cardioid r equals 1 plus sine theta. The area inside the blue circle and the red cardioid means inside both of these, so r equals 3 sine theta is blue, it's a circle. R equals 1 plus sine theta is red, it's a cardioid. The goal is to find the area between or inside both of them, So I just shaded in green the area that we're trying to find. And first thing we're gonna need is this intersection point. We need to know when the 3 sine theta and the 1 plus sine theta are equal for the first time as this path gets created, both the blue and the red. There's more than one intersection point. Right now we just are going to get this one. If we subtract sine theta from both sides, we get 2 sine theta equals 1. Therefore, sine theta equals 1/2. The sine of 30 degrees is 1/2, so theta equals 30 degrees, which is pi over 6 radians. So the intersection of this red cardioid and this blue circle is when theta equals pi over 6. This black line is making a 30-degree angle with the x-axis. That's the intersection. So the strategy here is going to be, we're going to find the area inside the circle from theta equals 0 to theta equals pi over 6, because this circle is swept out going from theta equals 0 up to, that's where the intersection point was. I don't really care what the r's are in this case. R is whatever. But this circle will sweep itself out. When it sweeps itself out from this theta 0 to this theta pi over 6, we'll get the area between the curve that's being swept out and the theta equals pi over 6. Because when theta is 0, the blue curve is here at the origin, and it graphs around this way. If we go up to where that pi over 6 line is, we'll get the area of this little section here. Then, so here's the theta equals pi over 6 again, over here, in the cardioid. This sweeps itself out from 0, 0 around, ends up back at 0, 0. So if we integrate this from here, which is pi over 6, up to here, which is 90 degrees, pi over 2, we'll get the area of this region between the red curve and those two rays. Theta equals pi over 6. And up here, this one's theta equals pi over 2. So we're going to find that area using the formula. And we'll find that area using the formula. If we add those together, so look closely at these two. If we add those together, this black region and this black region, if we add them together, we will get the region from here to here. So then once we have that, if we double it, we'll get the area that was requested in the original question. So I'm going to integrate, we're going to find the area from the blue from 0 to pi over 6. These are theta values I'm talking about, the 0 and the pi over 6. And then we're going to find the area of the red from pi over 6 to pi over 2. Add those together and we'll get this entire region that's shaded in black. And then we have to double that to get the area of the region that is described in this original question. So the area of the blue part is 1/2 r. For the blue, r is 3 sine theta. So 1/2 r squared d theta. And integrating that from, if we said that blue part is going to integrate from theta equals 0 up to theta equals pi over 6. That's to get this little sliver here. And then we have to add on the red part. The red part was this red region here is from theta equals pi over 6 to theta equals pi over 2. One half r, the r for that red part is 1 plus sine theta. 1/2 r squared d theta. So like I said, if we take these two and add them together, we're only getting the area of what I shaded in black here. So that has to be doubled to get the area in the original question. So double all this. And that 1/2, I'm not sure why I didn't put it to the left of the integral sign. And now we're going to distribute this 2 to both of these integrals. 2 times 1/2 is 1. 2 times 1/2 is 1. The 3 gets squared and becomes a 9, which can go to the left of the integral sign. The sine theta has to be squared in this formula, so we'll direct sine theta squared d theta from 0 to pi over 6. And plus the 2 out here has to multiply to this also. 2 times that integral. Well, there's a half there, so 2 times that is 1. Integral 1 plus sine theta. Quantity squared d theta. And this second one is integrating from pi over 6 to pi over 2. So, we will actually do this integration in class and show that this ends up equaling 5 pi over 4. That's the answer. the end.